Hi everyone. So I know that in the webinar we didn't have enough time to appropriately go through the results of the study we evaluated together. So I promise you I'm going to do a short video to kind of briefly explain what are the statistical results you are expected to look at and to what level you're supposed to discuss them. So these are the results from that study, about the studies. Now, the effect of water non-nutritive sweetened beverages on weight loss. So as you can see in the paper, there are two tables showing slightly different results. There's table number 2 and there's table number 3. Now the only difference between those two tables is that in table number 2, there was an intent to treat analysis done, which means that all participants that were recruited to the study and started the study were considered in this analysis, even though some of them were dropped out. This is the better way to calculate the results because it's more reflecting real life scenarios. Now, you may ask yourself, how do we actually consider those who dropped out? But there are some statistical tools and algorithms that allow us to do those tests and come up with predicted results. So this is table 2. So table 2 had the intent to treat analysis. So the entire amount of participants who started the study, the 320, I think. In table number 3, that table did not have the intent to treat. So this took the account, you can see it in the numbers, it's lower numbers, only the actual number of participants who finished the study. So here we do not consider people who dropped out. Now, which table should you have looked at when your evaluation? This one is probably better, the one with the intent to treat analysis that consider all participants. But in the assignment, I'm going to accept any of it, so it doesn't really matter. Generally speaking, this one would be better, but if you looked at the other one, that's fine as well. For the purpose of this little video, I'm going to look at table number 2, which considered all different participants. Now you can see there's quite a lot of details in this table. We're going to break it down. The first one is the result for the non-nutritive sweeteners group. This is the weighted baseline. This is the weight at the end of the study. And this is how much weight they actually lost in that study. This is the confidence intervals. I'm going to talk about it in a second. Same for the water group. This is their weight at the beginning of the study. You can see that it is almost identical, which is good, to the non-nutritive sweetener group. This is the weight at the end of the study. This is the average weight loss, and this is the mean difference. Now, the mean difference, what it says, is that we can say with 90% accuracy that if you are one of those people who can be considered part of this population that was studied in that trial, the 90% chance that following that exact protocol, you're going to lose between 5.42 to 6.47 kilograms if you are going to follow the protocol for the non-nutritive sweeteners. And we can be 90% sure that if you're going to follow the exact same protocol for the water group, you're going to lose between 3.59 to 4.60 kilograms after 12 weeks. Okay? So this is what the mean change says, and this is what's the 90% confidence intervals. So we can be 90% sure that the truth for this specific population is those ranges if you're in the non-nutritive, and those ranges if you're in the water group. And when I say for this population, we have to go up and look what's the population of the study. So I think we've got it here. So we probably can see the population here. So participants who, I think they had to be obese at the beginning of the trial, but anyway, you can see it in the method. We don't need to look at it now. So those people who meet the inclusion criteria, in other words. Okay. What's really interesting about the results and what we really want to consider is the differences between the non-nutritives to the water. So we can see that at baseline there was slight difference in weight between the non-nutritive to the water. We can see that the end of the trial, again, that's the difference between the two groups. And this is what's really interesting. So the change between the non-nutritive to the water group is that the non-nutritive group lost 1.85 kilograms more than the water group. And this is, by the way, statistically significant, as you can see here. The mean change, so we can be 90% sure that if you're going to follow the protocol for the non-nutritive sweeteners as comparison to the water, you'll be losing more. Your truth can lies in between those two numbers. So you're 90% likely to lose somewhere between 1.12 to 2.58 more than someone who's going to do the same protocol for the water. Okay, so there's a couple of things we need to look at. We need to look at the p-value, so the significance, which shows us the probability or the chance that this intervention going to occur by chance, or is it because of the intervention? Now this p-value kind of shows us that yes, it is likely to occur because of the intervention, but the magnitude or the size of the effect can only be determined by looking at the confidence intervals. So the confidence intervals in this study is the mean change or the mean difference, and we can see them here. So this is the kind of the magnitude of the effect, and generally speaking, we want to see confidence intervals that are kind of narrow, so we can be precise in our results. And this is something that I'm going to discuss more in next week's tutorial. So if it's not completely clear, don't worry, we will discuss it then. So again, just to sum it up before I'm going to the second point, there are two tables of results in this study. Table 2, Table 3. Table 2 had an intent to treat analysis, which means that all participants that started the study have been taken into account using kind of an algorithm. Generally, it is better to use the intent to treat results because they're better reflecting real life scenarios. Table 3 just taken into account the people who dropped out of the study. And you can see, by the way, that the results are not very much different. You can see them here. Now, a second point, and this is actually something that I forgot to appropriately discuss in the tutorial. It was a really good question that were asked in the forum by Cynthia, and I didn't answer it fully. So to understand that, and it was about the equivalence bond, we need to go down to the statistical analysis. So this study, and I think I did mention it in the tutorial, it was a little bit unique. It's an equivalent study. What means that we didn't have a null hypothesis here. The hypothesis of the study, the initial hypothesis, is that the results of the study would be that the water and the non-sweeteners will come to a very similar, or that will have non-significantly different results. So the hypothesis of the authors were, it doesn't matter if we're going to give them water or non-nutritive sweeteners, the effect going to be similar on weight loss. And you can see it here. So the primary hypothesis tested in the study was that water and non-nutritive sweeteners beverage treatment would be equivalent, but it cannot really be 100% equivalent. So they did set up kind of upper and lower bounds, and it was plus minus 1.7 kilogram. Okay. So the authors of the study said that if the results, the range of the results going to be in that scale, plus or minus 1.7 kilogram, then the primary hypothesis is going to be confirmed that water And non-nutritive sweeteners have a very similar effect. But if the results of the study showing wider range of results, then there's a difference. And as you can see down here, the results, indeed, there was more than 1.7. It reached up to 2.58, which means that the hypothesis is going to be rejected and that the non-nutritive sweeteners had actually a significantly greater effect on weight loss compared to the water. And this, where they explain it. So they say the mean weight loss differences between the water and non-nutritive sweetener was minus 0.885 kilograms, which is greater of the limit that was set. And therefore, they had to do an equivalence and paired comparison to conduct that. So in order to understand that complicated enough paragraphs, we need to go back to the statistical analysis paragraph and read that. But really important, and I want to make this very clear, and I think I said it in the webinar and I'm going to say it again. Reading scientific paper is really hard. Many times you come into sentences of paragraphs that you're not going to completely understand. You sometimes just have to ignore it and move forward and really just understand the bigger pictures. So where you're at as a research student in nutrition year 2, if you just understand the very basic principles, you're doing really well. So if you just understand what's a p-value and what's effect sizes, pretty much you're doing really good. And with the p-value, you just need to understand what is significant and what's not significant. And with the confidence intervals, you just need to understand that a wider range of confidence intervals means not very accurate or not very precise prediction, and with the narrower confidence intervals, or the narrower range of confidence intervals, we can tell with 90 or 95% certainty that the results of the study are much more, or the truth is a lot more precise. So the results are a lot more precise and reliable. I understand that this video still might be a little bit hard to understand. Again, it's something that we are going to discuss in some depth in the next tutorial, and I'm more than happy to do more videos to explain that. There's excellent material within the module's content with excellent YouTube videos to support your understanding. But as always, if you need further support, please do let me know.